All right, so today what we're going to do is we're going to learn about one more theorem that we can use to prove two triangles are congruent. Hypotenuse leg can only be used for right triangles. It says that if two right triangles, have a congruent hypotenuse and a corresponding congruent leg, then the two triangles are congruent. So this is specifically used for right triangles. Side, 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 angle, angle, side, angle, and angle, angle, side can be used for any triangle. So let's see how this works. This is number 3 on your example. So here we are given that line segment RT is the perpendicular bisector of line segment SU. We're also given that line segment RU is congruent to RS. So we want to show that these two triangles are congruent. All right, so the first thing that we want to look at is what are we given? So the first statement is that line segment RU is congruent to line segment RS. Well, we know that that's given. So our first reason is given. Now, we do want to make sure that we show what we know. So what I like to do is I actually like to mark that RS is congruent to RU, or RU is congruent to RS. So that way I'm following along on my diagram and I have a visual representation of what I'm given in the table. All right, the next thing is that angle RTU and RTS are right angles. Well, how do we know that these are right angles? Well, up here it says that they are perpendicular bisectors. Well, what does the word perpendicular means? It means that then they make a right angle. So now we know that this angle and this angle are right angles. So our reason there is definition of perpendicular bisector. Now that we know that these two angles are right angles, now we can say that these two smaller triangles are right triangles. So the definition of right triangle is why we know that. Now this next one, we're given the reason. So the reflexive property says that a segment is congruent to itself, or an angle is congruent to itself. Well, since we're looking at triangle RTU and RTS, we want to know, well, we notice that they share this segment right here. So RT is congruent to itself. So again, I'm going to mark this on my diagram that RT is congruent to itself, and then I add that to my statements. The last thing is now we have that RU is congruent to RS, that's the hypotenuse, and RT is congruent to itself, that's a leg. So now we have enough to say the triangle RTU is congruent to RTS by hypotenuse leg. Now, is there another way to prove these two triangles are congruent? Let's take a look. So, our first reason is the same. It's given. So again, I'm just going to remind myself that RS is congruent to RU. Then, they're right angles, same reason, definition of perpendicular bisector, and again, I'm going to mark on here that these are right angles. This is not necessary to label the diagram, but I find that it helps me. All right, these are right triangles, again, definition of right triangle. But here's where it changes. Instead of using the reflexive property to show that RT is congruent to RT, I'm actually going to show that UT is congruent to TS. Well, why is UT congruent to US? Well, remember we said that RT was a perpendicular bisector. So we used the perpendicular part to show that they're right angles, but the bisector part means that it cuts it into two congruent parts. So now we can say that UT is congruent to ST. Now, we can still show that these two triangles are congruent because we have a hypotenuse in UR, a hypotenuse in RS, and instead of using the RT, the share side, we know that UT is congruent to TS. So we can still show that these two triangles are congruent by hypotenuse leg.